So from this we can write one statement, that is, what is that statement? If you double the distance between the two bodies, right? If you double the distance between two bodies, if you will double the distance between two bodies, if you will double the distance between two bodies, if you will double the distance between two bodies, all of you write. If you will double the distance.
This is for worst case.
No, both I am giving the statement. Okay, understand?
Both one statement, sir.
Single statement, both combined. Okay.
Okay, sir.
You double the distance between two bodies. If we double the distance between two bodies, the gravitational force become how much, Ra? 1/4. The gravitational force become 1/4. The gravitational force become 1/4. The gravitational force become 1/4. 1/4. And if you halve the distance, if we halve, what do you mean by halve, Shruti? What do you mean?
Half.
1/2 half.
1/2. Halve means half. What is Monish? Halve means what? Half. Remember that.
Half.
Halve means half. Okay? Okay? That is Laksha, everybody right. Halve. If we halve the distance between, if we halve the distance, gravitational force next up. Gravitational force becomes 1/4. Gravitational force become 1/4, and if we halve the distance between two bodies, if we halve the distance between two bodies, halve the distance between two bodies, comma, then the gravitational force becomes how much, Ra? Pradosh? Then the gravitational
4.
becomes 4 times. What is that? 4 times.
4 times.
4 times. Understand? That is. Now, all of you listen and keep note. All
The distance between two
bodies, comma, then the gravitational force becomes 4 times. Then the gravitational force becomes 4 times. This is what we have got. Understand, Elmokil? Clear? Monish? Now, observe very carefully, guys. Here I want to say you again one more thing. This Newton's law of gravitation, also we can call it as what? Universal law.
Newton's law.
Universal gravitational force.
Called as universal law of gravitation. If you know the mass of two bodies and if you know the distance between two bodies, they are big or small, doesn't matter. They are too big or too small, also doesn't matter. Everywhere we can use what? To calculate force between them, we can use this formula. And this is what? It is independent of masses, independent of distance between them, and also independent of what? Matter between them. So that is why this is called as what, Ra? Universal law of gravitation. Understand, Ra? So whether the bodies are celestial or terrestrial, doesn't matter. Means in a sense of, what do you mean by terrestrial bodies? Anybody? Terrestrial, celestial.
which contains land are called the terrestrial, sir.
Yeah. Terrestrial bodies means which are on the earth. Understanding? So the body is present on the earth or not, doesn't matter. The body is present in celestial. As a Shruti, what do you mean by celestial, Shruti? Outer space. What is that? Outer space. Understanding?
Outer space.
Stars, planets, and satellites. Wherever it is, we can use. That is why we used to call it as universal law of gravitation. So 2 words you should know the meaning. What is that? Terrestrial and celestial. All of you write. Terrestrial. T-E-R-R-E-S. What is that? T-R-R-E-S. Terrestrial. T-R-I-A-L. T-R-I-A-L. Terrestrial bodies. What do you mean by terrestrial bodies? On earth. What is that? On earth. Next one. Celestial bodies. Celestial bodies means in the sense of what? Outer space. Understand? Like stars, understand, planets, etc. Okay, Ra? Okay, guys? That is. Okay?
Sir.
That is why this Vashini?
Yes, sir.
Call this one universal law of gravitation. Universal
Law of gravitation.
gravitation. Understand, Ra? Shruti?
Yes, sir.
That is. Now, for our today's class, last one, we will calculate what is this units of gravitational constant. Later value we will study in the next class. So let us go with the units of gravitational constant. All of you keep it in. Units of, what is that? Units of gravitational constant. What is the symbol of gravitational constant? Anybody?
Capital G.
Capital G.
Capital G.
So let us see how to find the units. Very simple, Ra. So now, what is the formula? Universal law of gravitation formula. Tell me, everybody. What is the universal law formula?
Sir, F is directly.
Read.
Sir, F is
Equal
equal
to
to
G
F is equal to
M1 into
M1
M2 by R
by
square.
R
into
square.
by
Universal law of gravitation. G
R
into
square.
mass into M1 into M2
To
divided
M2 divided by R square.
R square. Correct or not? Now, we want units of force, not. We want units of G. Now, keep G one side and remaining all send another side. Now, R square is in division here. Will come this side. It will become what?
multiplication.
M2 together. They are in here multiplication with the G. So they will come this side. What will be? They will become division. Yes or no? Yes or no?
Sir.
Yes, sir.
Based upon that, now G equals to what is the formula? Let me see who will say. What is the G equals to formula? G equals to force into distance square divided by.
M1 into M2.
Understand? Ra? I think Monish also understand very well. Yes, Monish? Can I believe you?
Yes, sir.
Yes,
Yes,
sir.
sir.
That is. So that's all. So if you'll understand this, you can understand now. So as we know, you people tell me, all the SI units tell me. What is the SI units of force? All the SI units. Force equals
Newton,
what is the unit?
kilogram, meter per second.
Equals rate. Force is equals to Newton.
Kilogram meter per second square.
Force is equals to Newton.
Newton, sir.
1
Understand?
Newton.
Yeah, Newtons. Next. Distance. Distance what? Ra? Distance, what is the formula? Distance. Meters. What is that?
Meter.
Meter.
But here,
Meters.
distance square. Distance square. What is it will come?
Sir, yes, sir.
What it will come? Meter square will come. Next. Mass. What is the mass? Mass is equals to
kg, sir. Kg.
kilogram.
kg.
Kilogram. That's all. So substituting this in above formula. What will come? You check it. F is equals to what? Force is equals to into R is equals to what? Meter whole square
Square.
divided by mass is
by
equals to what? Kilogram
kg into
to
kg.
kilogram.
kg into kg.
That is so, which is equals to capital G. G is equals to what will become? Newton meter square per
Second square divided by
kg
kilogram
square.
square.
I can write Newton meter square kilogram minus 2. But what I said in exam always what you have to use? You have to use this one alone. Okay, guys? Nobody
Yes,
should
sir.
use another one. Understand, Ra? Nobody should use this one because cancellation time very difficult. Remember, calculations in this chapter 1,000 times tougher than first 2 chapters. Understand, guys? 1,000 times tough. So that is why be very, very careful with the calculations. So I hope you understand, Laksha. What is the G value? What is the unit of G? What is the unit of G, Ra? G equals to force into. Understand? R square by F1
R square
into.
divided
That
by
is the formula. So unit is equals to what? Newton meter square per kilogram square. Understand?
square.
All of you? Newton meter square.
Sir,
Kilogram square. So 2 formulas you have been learned today. What is that formulas? Force F is equals to gravitational constant into M1 into
M1 into M2 divided by R square.
distance
R square.
R. Second formula, gravitational constant is
G
equals
is equal to
force into distance
M into R square divided by M1 into M2.
So here R indicate not radius. What is that? Distance between the
Meter.
centers. That is you should remember. Distance between centers of 2 bodies. Centers of 2 bodies. That is. Okay, guys. So this is all about the today's class. With this, I will stop the today's class. Then tomorrow we'll calculate what is the value of gravitational constant. What is that? What is the value of gravitational?
Gravitational constant.
What is that value? That is all we'll do, and we'll calculate that value also directly. Is it okay, guys? Understand, Ra?
Sir.
We will
Yes, sir.
calculate
Understood,
that
sir.
value also. Because everybody will know only that they will by heart that value, but we will learn how to calculate, and that directly, lively, we will calculate that value practically also. Okay, guys, with the numerical method. Okay,
Sir.
so this is all
Yes,
about it.
sir.
With this, I will stop the today. I hope you all understand very well. Any doubt means you can ask me. Darun, I will send the PDF. You have to copy this one exactly. Understand, Darun? Units of. This one is important. Units of gravitational constant. Okay, Darun, respond me. Just see. R is going to this side. R is in division here. Will come this side. What will become, Darun? Multiplication. Okay, Darun. Next, M1 and M2. Masses are is in multiplication here. So they will go that side. Will become what? Division. So like that, I modified the formula. Is it okay, Darun?
Okay, sir.
Later, I have been found the units. That's all. What is the unit of force? Force, Darun? Newton. Correct. What is the unit of distance? Meters. Okay.
Yes, sir.
What is the unit of mass? Kilogram. Okay. That units I am substituting exactly. Force Newton, distance meter whole square. Square is the square. Mass M1 kilogram, M2 also kilogram. So I am multiplying Newton square meter, kilogram into kilogram. What, Darun? Kilogram square. Okay. That's all. So that is the unit of capital G. Somebody will ask you, what is the unit of capital G, Maunesh? Newton square meter per kilogram square.
Kilogram square.
That is, you should remember. So with this, I am going to stop the today's class. I hope all of you understand very well. Any doubt clear, guys? Elmokil, Shruti, very
Yes, sir.
important in our future. +1, +2 also. JEE NEET also. It is very, very important. That is, you should remember. So thank you all of you. Bye. Again, we'll meet tomorrow.
Thank you.